Well, hello, everybody. I'm Dr. O'Malley here at New Mexico Tech. I'm a mechanical engineering faculty. I'm joined by Thomas, who's a PhD student in the physics department. And we've got a couple of demonstrations and talk about some of the STEM programs here at Tech. So um, my project here at Tech is Robot Combat. I lead a group that puts together I have student-led projects where they build robots and then they do tournaments here on campus in November and April every year. And we also do outreach at Explora, where we teach students to build robots, as well as at some middle schools and high schools around the state when the teachers are interested. So a bit about the program. This is the Robotic Combat Outreach Program here at Tech. And I'll just jump right into showing you some videos from last year's April tournament. All right, so here's the New Mexico Tech Robot Combat STEM outreach page. We've got YouTube videos of some past tournaments, the upcoming tournaments, some workshops our students lead at Explora and at high schools around the state, and just some articles on some of the past tournaments. I'm going to jump over to the YouTube site. And so these are two videos put together by teams last semester. These are the robots from last April. These are ones designed by our senior students. They're 3-pound robots. And as you can see here, they've got a little bit of a description of the major components, the exploded view of their design, and then a little bit of background on the bot itself. Right, the point of the competition is to attack the other robot and cause damage, hopefully knock it out. Right, so they win a match either by completely disabling the other robot or causing the most damage. If neither bot is destroyed at the end of 3 minutes, then there's a scoring mechanism that comes in based on how aggressive they were and how much contact they had. So in this case, there's a clear winner. One of them ripped the weapon off the other. Excuse me. And then this one, we've got the wedge-shaped robot that I built and the bot from the first match, the winner from the first match. And there we go. Mine then succeeds in taking the front end off of the other one. So they'll cut to a little clip here and show first the end of the match and then the damage that was done to the bot. So we see we had a fully 3D printed frame and it couldn't take the impact. So this is a video made by the other team of their robot. If you go back and watch with the audio later from the YouTube site, they got a little bit of background on the team members, and then we take a look at the bot itself. So this one had a saw blade for its offensive capability. And basically, the students are designing these as part of their senior design project. They're looking to learn about design. They get to actually, with this project, use the bots and see what happens, and then come back the next semester and design improvements to the bot. Or start over building on the knowledge that they have from the bot before, or the matches before. All of the bots, they machined most of the primary components themselves and put them together and built just about everything on the bot themselves. All right, then we end with a little bit more video of the match itself. I've got a few other things to show you here in the room. The camera's now pointing down at the arena. So in the arena, I have 3 different bots and a dummy. The first bot is one that we build with the middle school and high school students. It's just foam core board, an Arduino, and several other components that we talk through in that program and introduce them to some basic electronics and basic coding. Start out with a robot like this that has forward functionality and steering, but can't go in reverse. Right? And can't go in reverse because we want them to learn to code that in themselves. So it's functional until you get to the corner, and then it's stuck. Right? We work on the code with the students a little bit, and then we end up with a robot more like this one, which is all the same hardware, but an improved code. And it can go in reverse. Still some more improvements that could be made to it, adding additional weapon component or improving its speed. Again, most of that is just a function of the coding and a little bit of how we put it together. So I'm going to go and park these 2 in the corners. And then our third robot is the one from the video. That is much more destructive, much faster. Spent a lot more time coding and developing specific components for this one. I think I pushed the little thing in the corner, so we'll bring it back out. I'd asked you to look at the video from the last matches and think about what made one bot better than the others, right? Was one faster, slower? Do you think one was better able to deal with the impacts, absorb the impacts from the others? Do you think, what other types of weapons could be designed, right? We only had 3 bots here, and the ones that I have in the room are all similar. There are various stages of design. You could call one a prototype, one a slightly advanced prototype, and then the one that I've got in here now, or the final version. And then from that, what would you do with your own if you were to do a project like this? So with that, talking about some options for other types of weapons, I'm going to turn it over to Thomas, who's out on our rugby field and has a physics demonstration.
Hi, everyone. My name is Thomas Godden. I'm a graduate student in physics at New Mexico Tech here. Physics is not quite like engineering. We don't really spend most of our time building. Instead, we spend most of our time thinking about energy and how we can use energy to our advantage. And so I've been thinking a little bit about theoretical weapons we could add to our battle bot. So I wanted to demo one of them and show you an idea I had for a second one here. So we're going to think today about a wrecking ball and a blaster that might be able to attack long range using our BattleBot systems. So I'm going to do a demonstration here using our wrecking. I don't have a wrecking ball with me, but I do have a setup here for this pendulum system. So I have hooked this bowling ball up to the rugby goalpost, and we can use it to sort of approximate what a wrecking ball might look like on a BattleBot. And what I wanted to do is sort of think about, if we're going to swing this at an opposing bot, we got to know exactly where we're going to swing it and exactly how far it's going to go out and it's going to come back. So we know we're not going to hurt our own bot or we're not going to hurt or that we are going to attack the other bot successfully. So today we're going to use this bowling ball pendulum with me as a demonstration piece, and we're going to try and figure out if I pull this bowling ball back and let it swing, am I going to have to worry about having to move out of the way? Is it going to come back with enough energy to knock into me or cause me to have to jump out of the way? Using our knowledge of physics, we can say that however much energy we're going to give something is however much energy it's going to have. So if I pull this bowling ball back, we know that it only has as much energy as I'm going to be allow it to have via gravity. So we're going to see if that energy is going to be enough for it to come back and cause me to move out of the way. So if I pull this bowling ball back and we let it go, I don't ever have to move. The bowling ball comes over right back to my chest. It doesn't ever go any farther up. It can't go any farther than I let it go. So it always comes back to the same height, and then it will come back and start swinging down. So if I were to let it go again, it would just keep swinging down and down until it stopped again. That's because it can't gain energy, but it can lose energy. So if we're thinking about our BattleBot systems here, a wrecking ball might be a good type of system because you can predict exactly how it's going to swing. We know if we swing it back so far, it's going to go so far forward. We could even, if I had my students here, I'd maybe do calculations about how fast it might be moving when it got to the bottom of its swing, which could be useful in designing a battle bot. I also wanted to share with you a second system. The physics club couldn't be here today, but they designed an air cannon that's about 25 feet long and can fire objects hundreds of yards. So I wanted to show you video of them firing this system because it's really cool looking, and a blaster would be a really cool design for a battle bot. This is a video of our air cannon that was built by the physics club. This thing is about 30 feet long. It's got pressurized air down here in the base, and when you fill this thing with pressurized air, it gives the projectile a lot of energy, and they can actually use it to launch whatever they have in that barrel for hundreds of yards. So let's see what happens when they fire it here. So this is a very short video of it firing. You can sort of see our projectile leaving the barrel of our air cannon. I'm going to show another one, though. It shows you exactly how far we can get this thing to go. So let's go ahead and show you the second video here. I've got this one ready to go. So this one shows you exactly the range this thing can have. So we brought it out over to Emmertech, which is the big blasting range on campus, and we let it fire again. You can see it travels a really long way all the way over there. So, another design system that we could use for our battle bots is to have some sort of blaster that can attack its opponents from across the ring. So yeah, these are the two demonstrations I have and some of the ways that the physics department might be able to help out with Dr. O'Malley's BattleBots project here at New Mexico Tech.
All right, well, thank you for joining us today. We've talked about some BattleBots that the students build it here at Tech. I've shown you the arena and some of the bots that we build with middle school and high school students. I can show you a little bit more, or talk to you a little bit more about that program. So like I said, we've taught it at Explora a couple times now, and at a couple of different middle schools and high schools around the state. And basically, we look at taking the Arduino code and putting it into a bot that the students design the frame for, and then we take the code and we take it apart, and we look at, these are the primary components. This is what tells it to go forward. This is what tells it to turn, how we interpret the signal from the transmitter receiver, and then we go and apply some basic algebra to it to convert those signals into commands for the motors. Right? Once we have the commands for the motors, then we can drive it. Talk about how the electricity flows through the system, some different signal types. Right? There's the signal that comes from the transmitter receiver is very like the Wi-Fi signal that you'd have on the internet, but the signal within the robot that controls the motor is very different from that. And so the Arduino, or the brain of the robot, needs to interpret between the two and take those commands and cause it to act. So basically, we start off with a code that only goes in forward, and then we look at it and we figure out what we need to change, how we make a mirror image of it to handle the reverse functionality. So with that, I want to thank you all for coming today. I hope you enjoyed the physics demonstration from Thomas and seeing the robots here in the lab. If you'd like to see them in person, watch for the next time we go up to Explora, or come on down to campus in November or April every year. Check out the website to see when those are happening. The next one is November 6th this year, but if you're watching this video after November 6th, there'll be another one, don't worry.